Welcome dear students in question number 54 of NSEP 2022, and question is: a long uniform rod length L and mass M is pivoted vertically on a horizontal frictionless pivot at its lower end. The rod is released from rest in its vertical position OA. See figure. It falls off without slipping at O at the instant the rod is horizontal. These are four options. And this is the rod and this is length L, and it is pivoted at point O, at this point. And when the rod is released from rest, it is the path of the upper end, means point A, is just like this, and this is the horizontal rod. And if I calculate the potential energy of the rod when the rod is in vertical position, then the potential energy of the rod, it should be potential energy of rod when it is in vertical position. Then we know that the potential energy is mgh, and here we have to take the length from the center of mass, that is L by 2. It should be the height, so it becomes mg L by 2. And we know that when the rod release and it falls down in and comes in its horizontal position, then potential energy is converted into the angular kinetic energy. So angular kinetic energy, we know that should be equal to half I omega square, and it should be equal to mg into L by 2. And in this position, moment of inertia, it should be ml square by 3. This is the formula of moment of inertia. So it becomes half ml square by 3. This is moment of inertia. Omega square equal to mg L by 2, and it becomes m cancel out and 2 cancel out. Omega square L square upon 3 equal to GL. L cancel out and omega equal to 3G upon L. This is the angular speed, under root 3G upon L. And now we can check the option, and in option 1, I think angular speed is under root 3G upon L. It should be the correct answer. Answer A should be the correct answer. And now we solve for the another options, and we know that the torque is equal to I into alpha. And we know that torque is equivalent to the potential energy. The potential energy should be converted into the torque, so it should be mg into L by 2, and moment of inertia is ml square by 3 and into alpha. So if we calculate alpha, we can cancel m, and 1L should be cancel out. So omega square equal to 3G upon L, and omega becomes under root 3G upon L. And if we see the options, angular speed is under root 3G upon L. Option A is correct. And as we know, in this question, more than one option may be correct. So we will try to obtain the angular acceleration. So we will calculate the torque. We know that torque is I into alpha, and torque is mg L by 2, and I is ml square by 3. We have already used into alpha. Now m cancel out, and it should be ml square. 1L should be cancelled out, So it becomes G by 2 equal to L alpha upon 3 and alpha equal to 3G upon 2L. 3G upon 2L. So angular acceleration is 3G upon 2L. So option B is also correct answer. So in this question, option A and option B. Option A and B will be the correct option. Will be the correct options. So thank you very much, dear students. We will meet again with the solution of another question.